Good morning. My name is Osvaldo Bascur. I work with OSB Digital and Seeq Advanced Analytics. Today we'll share these integrated rock processing strategies in the digital age. This is the partial presentation, and if you need the larger presentation, just let us know. Um, the agenda for today consists of the digital age transformation secrets, which is very important for this type of presentation today. There are 4 steps to maximize the metal production in tons per hour. The dynamic support using hybrid models and predictive analytics is going to be presented and discussed. And real life examples of what the companies are doing are going to be shared and some conclusions drawn. Basically, what happened is that when we start processing low-grade ores with less than 0.5% copper or some other minerals, we are really dealing with the rock, with the matrix of the rock. So the georheological properties becomes extremely important, and the transport of pulp through the sack mill, ball mill, cyclones, flotation, and thickening due to the size distributions and the density and the percent solid represent a big problems, and there is many issues that needs to be taken care of, so we don't have delays, we don't have downtimes, and of course if that's those operating process occur, we are losing a lot of energy and we are losing a lot of water that is not used correctly for the real production at the target that was presented or planned by the production planning. So the idea is to really integrate both the mine and the mill together to maximize the productive times of all the pieces of equipment at the right production rates. There are that's why we need to reduce these variances between the production and the operational resort. But for that, we need to clean the data that is collected in historians. And there is a tremendous amount of information which is missing for improved decision support. So we need to look for that so management can have access to it and the decisions becomes much easier and much productive. Grinding dynamic model with the viscosity model is used today, and also the flotation air holdup profile to really find the optimal throughput without violating process constraints and maximizing the copper production rate in real time. So we need to choose these KPIs in the digital age correctly, cleaning the data, adding the right context, and to have effective communication between the mine, the production people, operation, and support. And avoid these hidden production losses, as I was saying, because the mills gets overloaded, the cyclone gets roping, the flotation cell, the material that is coming from grinding, in, you have problem with the dart valves, the impeller gets corroded, and all that rock that is going through goes to the thickeners, having tremendous problem with the flocculation and the water recovery. So those are the things that today we can take care of it and improve the overall plant effectiveness. So we have this innovation that happens in the operational process using the cloud. Digital disruption is very important today because it promotes this dynamic milling and mill performance management. People are very important part of of this process. Business processes change. We can work remotely. We can support the plant remotely. Everything can be done completely different as we used to do 5 years ago. And the new technologies are available to populate the models, characterize the parameters, and really do that in real time according to the type of ores that we are producing. So this is what we got today. We call it Spreadsheet Hell. So a lot of spreadsheets here or there. That's not the way to go. Of course, the management is not receiving the right information, so very bad decision making. Everybody's having silos. Uh, Key thing is to have the data that is collected transform automatically using the new technologies into insights to develop production models for improved decision making. In this case, we are going to share the synergy between the Pi system historian and Seeq that enables us to create the models using the proper data with the right events of the production, as you are going to see. Basically, Seeq is basically environment for analytical with analytical engine that engineers and subject matter experts can look at it, document, and develop models in real time, and then present that to management in the organizer. And if you want to do even more data analytics, it's all possible because having a good set of information is really the key. So the first step is develop a digital twin plant, followed by the identification of production losses due to the rheology and the georheology of the plant, and and characterize those so we can develop the models with those constraints in mind and push the plant to the maximum copper recovery and then implement. So the model is based upon objects which are crushing, grinding, flotation, thickening, tailings for the whole plant, and we are managing the energy, the flow or the fluidity of the pulp through the plant and recovering or adding the right amount of water to maintain that viscosity and the energy so we have a real fluidity as we are processing ores which are pipe and copper, meaning that most of what we are producing in this diagram is rock with a little bit of concentrate and a lot of waste. Power is one of the 60 to 70% tickets, and water also. So we do the model by getting the process flow diagram of the plant. We characterize those three units, and we have the rock processing first. Then we get the bulk concentrate, and we clean it up, and we get the moly and copper, as depending on the plant how you want to do it. This is Dynamill. It's a model that has been going on over the years, but now because of the data, the cleansing, we can have it in real time. As you can see here, we are modeling the rheology. We are calculating everything that happening in each of the cyclone banks, and we're calculating the net and metal recovery as we go, so we know the effect of the water in or the rheology in the plant because we know the type of mineral, we know the density, so and we have the correlations and the equation, and here is the plant. So you can move and see that in real time. We got the particle size distribution coming in, particle size distribution coming out, and you can see here we added water, and you can see the effect of the particle of the P80 going down. We have the particle size distribution here as well, and so on. So the second step is to characterize these hidden losses that we're having, because if we push the mill today, you are going to have a mill that's going to overflow, the hydrocyclone is going to start roping while you are maximizing the throughput. The recovery also goes down to a certain extent, and then you have to get the right size distribution with the minimum variation so you can push closer to the constraint, identify the constraint. These are changing, so you need to have predictive analytics for those things to be done correctly. This is just showing one case of analyzing the throughput. You can see here when we are low, we get pretty good recovery, but as we push, the recovery start going down, the metal copper production goes up, and then of course start going down as we increase the throughput. And this is the P80, or we call it the grind cut as we discussed. But this is the business cut point for the maximum production of copper. So you stick with that one for that type of ore and you move ahead. Here is showing the restriction that we have in the plant with the work that we have done at the University of Concepcion. Here we got the 77.8% as the threshold where this become very, very nonlinear. This has been identified early on by Free and Horst in 1977. We also identified that probably at the same time when we did these experiments, and then we wrote additional papers to diffuse this information because it's such an important thing, and we included this with Free Herbst in the what we call Optimill and the Dynamill operational model that we are discussing today. So this is where we identifying the losses, we characterize it. I don't have time to do that, but that's very important to see the effect of the type of ore, and the rheology of the plant is characterized very well. Then we can go into predictive modeling where we take this model that we have and we characterize it, but we need to have tools that enable us to model the grinding, model the rheology, model the flotation, and then identify these soft sensors, because the sensors that we have in the plant, like this PSI, they're always having some little problems, so the control strategies don't work well. So if you have an observer like this model and you can run it 100% of the time, then you are going to have a tremendous better control and also understanding what the P80 is based upon the type of ore, the stockpile level, the sack mill behavior, the ball mill behavior, the particle size, distribution shape of the feed, which is varying. The P80 is not a good number, so you need to look at the slope of that distribution, making sure that it's always kind of sticky. And we got the power, the water, the amperages, you name it. All those that are here increases the observability of the plant so we can move that correctly. Get it into the flotation. We looked at really this is a zero order process where if you move this variable here, which is the QT for each of the cell, it produces a tremendous change on the way that the particles are attached, detached, and the way that the froth is processed, the cleansing of it. And this is due to this model that is running in real time. You can see the froth changes as you change the aeration or you change this one. It's very interesting on how this interface is really managing the froth. So really this is related to the percent air that we have in the impeller area and the percent of air, which is about 80% in the froth and 10 to 15 to 20% in the pulp. Having that characterization correctly, as you can see here, uh, the holdup of the cells in the profile that we get, we can really further to identify the right liberation through the P80 and the slope of the sizes that are feeding the flotation and the turbulence that we are applying. We apply the model that's called Dynafloat, and that's enabled to identify what is the best strategy to get as much copper and calculate the recovery in real time. So this is the metal recovery coming out from the roughers. Also model using Seeq advanced analytics to really understand what is the effect, what happened if we change this, what happened if we, so we know what to move, the latitude that we knew, and then we can implement many findings. The many findings that not only the particle size distribution is affecting the flotation, but it's also affecting the equipment, as you can see, the flooding or the amount of segregation that happen in these cells, and also its affected distribution affects the thickening and the water recovery. And also today we can have the model of the whole plant using Python and another, because we do have the constraints. So we know the constraints, we know the data, we can correlate the data, and that's what's happened. We get the full view of the plant. So today with the cloud-based visualization and collaboration is a big change on how we can do and optimize this rock processing for lower uh, ore grades. So what we need in conclusions is that we need a very important is to have a good access and nomenclature, which is really what we call a digital twin plan, which is a mixture of having the right variables and the right models that can transform the data into information by the user at the desired degree of detail, so to come up with the right foundation. We use these hybrid models because you have information that increase the visibility of the unknown. So first step, as I discussed, is to have data and events, transform that into information so we can run the model, we can characterize the models with the right type of ores. And then Seeq and advanced analytics enabled to have dynamics decision support in the mining complex and also to have adaptive models that are changing according to the type of ore. The Pi system and Seeq is a tremendous synergy that can be used in a very practical way by subject matter expert anywhere they are because it's running in the cloud. So you need to adapt your organization with a new team that really can access and use this environment. So that's why we are offering coaching to get these things running much quicker than if you do it alone. Improve the operational efficiency and sustainability for lower copper air is really what we're really doing here. So if you have any question, please let us know. My name is Osvaldo Bascur, and we can have a conversation.